Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And I'm Austin. For math homework help, call in Bakersfield 636-4357, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net, and on social media, Facebook, Instagram, and Twitter, and YouTube.
All right, nicely done. So, Austin, where do you attend school and what grade are you in?
Rosedale Middle School, 7th grade.
Rosedale Middle School, 7th grade. How is 7th grade?
Good.
Is there anything bad about it?
No.
You're looking forward to 8th grade?
Yeah.
Do you think you're ready for 8th grade right now?
No.
No?
Okay.
Okay. But 7th grade is going pretty smoothly so
Yeah.
far. All right. Now, we were talking a little bit before we got on air, and you had an opportunity to go to Cooperstown this last year, right? Because you play baseball. And have you been playing ball for a long time?
Yeah. Yeah.
How long?
Probably like 7, 8 years.
All right, so you've been
Yeah.
playing for a long time. Do you have a favorite position or something that you play more than others?
Pitching, second. Pitching and playing second base.
Okay. Do you prefer one over the other?
Second base probably.
Why?
Because like you get to field more
Okay.
when you pitch.
So
Cover a lot more
you don't
ground.
want to
Yeah.
have to hold the ball and
Yeah.
do that every single time, right? You're like,
Yeah.
if it comes to me, I'm cool and I'll make all the plays.
Yeah.
So you said that at Cooperstown you had a lot of fun. What was the best thing about Cooperstown? Whether it was playing the game or the Hall of Fame or something different, could be.
Probably just being with like the team, being with all my friends,
All right.
and then the fields were nice, really nice too.
Yeah.
So
it
are
was
they
cool.
nicer than the ones here?
Good
Yeah.
condition.
Well, that's the Hall of Fame, right? You would
Yeah.
expect Cooperstown to have the best fields, right?
Yeah.
All right. You ready to help do a social media problem with me right now?
Yeah.
All right, let's take a look at it right now. So every day we send out a math problem of the day on different social media, and people send in their guesses as to what the answer is. So what is the greatest common factor of 57 and 96? So Austin, do you have any idea what greatest common factor even means or what to do with that?
Greatest common factor is like which one has like is the biggest number. That's a common factor of one of them.
Okay. So what would you think of when you see 57 and 96? Are there any of those options up there that you know you could get rid of?
5 for sure,
Why 5?
because they don't end in like they don't end in a 5, and 5 only ends in a 5.
Or a 0,
Yeah, or 0.
right? So neither one of them end in a 5 or 0. So we know D is out of the way.
Yeah.
So what do you want to do now as far as 3, 9, and 1?
See which one like lines up.
So let's think about 57. What numbers would go into 57? We know 1 will, right? Obviously, 1
Yeah.
and 57. Will 2?
No,
Why not?
because it doesn't have a prime number. at the
Even
end.
number.
Even number. Yeah.
It's not an even number, right? What about 3?
3 is an odd number.
Okay.
And
So do you think 3 would go into 57?
possibly.
Is there a way that you could check just with anything that you know about numbers like 57 to see if it's divisible by 3?
Like the ending number.
So, well, with 3s, there's actually an interesting thing you can do. If you add up, so with 57, we have the digits 5 and 7, okay?
Add
If
them.
you add up the digits of a number, and it's a number that you can divide by 3, then you could divide that value by 3. So if we add 5 and 7, what does that get us?
5 and 7, 35.
No,
Well,
if we
5
add
and
them,
7.
right? If we add
Oh
them.
yeah.
So you get 12.
12.
Will 3 go into 12?
Yeah.
So
4
that
times.
means that 57 is divisible by 3, so 3 is a factor. Now, is that the case with 96 as well?
Add 9 and 6, and what do you get?
12.
9 and 6 is 12?
Or 9 and 6 is 15.
There you
Okay.
go.
Can you divide 15 by 3?
Yes.
So you can divide 96 by 3. So we know that 3 is a factor of 57 and 96. So is
So
it a
9.
common factor?
Yeah.
Okay, so let's talk about 9. Is there anything we know about visibility rules for 9 to check to see if we could.
What's 9 times 10?
9 times 10, 90.
What's 9 times 11?
99.
So 90 and 99, is 96 going to be divisible by 9?
No.
No, so what's the answer going to be?
3.
There you go. Let's take it. You sure?
Yeah.
All right, let's take a look at it. There you go. 3 is the correct answer. Nicely done. First problem done today. Hey, do remember we have home tutors available on Tuesdays and Wednesdays between 3:30 and 5:30 most of the school year. Austin went through all of the different ways that you can get in contact with us. And right now, it is time for today's Math in the News. All right, today's Math in the News, this is something pretty exciting because it just opened up at the beginning of October. And this is the Sphere in Las Vegas. Have you heard about this?
Yeah.
What did you see any of it yet?
Yeah, yesterday.
Yesterday, you saw some of it?
Report, yeah.
Okay, so let's take a look at some footage that we've got right now of the Sphere. And there it is. This is the largest sphere, and it's in Las Vegas. It's right on the strip right there. You can see all of the amazing things that they're able to show on the outside of the sphere is what you're looking at. And if you could put anything up there, what do you think you would want to put out there?
Probably just like a welcome sign. Like
Okay.
to the-
Did you ever see the one with the eyeball on there?
Oh, forget, no.
That,
no,
you
I'm
know,
gone.
that-
I'm
that's,
done.
That's a
I'm
pretty
done.
creepy one with the eyeball right there. But you can see a lot of things. This is the inside
Oh,
of the
this is
sphere.
the one we saw yesterday.
Right, so this is inside, so they have shows in there all the time, and there is a residency going on with the band U2 right now, but you can see how IMAX used to be a big thing, right?
Yeah.
This is taking everything even a step further right there with the Sphere, and it opened up, and I guess, we make fun because being New York fans, the Knickerbockers and stuff are always looking to put a pretty good team on the court, and they can't do that. Yet the guy that owns the Knicks can put this thing together and make money off of this
I think
thing.
it was about, what, $2.3 billion
Yeah,
to
it's
put
a lot
together?
of money. So we need to figure out the math behind it, right? Because it's called Math in the News, right?
Yeah.
So let's take a look at some of the math behind the Sphere that is in Las Vegas. So as far as putting it together, the area of a sphere. Have you worked on any of this in geometry yet in 6th or
No.
7th grade?
No.
Well, guess what? I'm sure you go into in 7th or 8th grade. Take a look at some of the geometry that you're going to do, and at the area of a sphere is one that you'll probably work out first, okay? Then the volume of a sphere, and you can see we've got these different formulas here. Not that you have to memorize those. If you knew them and how they worked, it would be a lot better for you as you start getting into geometry and stuff like that. But a lot of these things you'll have handy for you to look at, right? Because you don't want to have to memorize all of these formulas. But we can see as you get into higher mathematics, some of the, do you know what a geodesic dome is? Have you ever seen one or heard of one?
No, we haven't learned about that yet.
Okay.
Have you been
So
to Camp Keep?
sometime
They
you'll
have one
see-
at
Yeah.
Camp Keep,
Oh,
right?
yeah.
Yeah, they've
We've been
got
to Camp Keep.
geodesic domes over there. They're comprised of triangles because they're more structurally sound
Yeah.
than other shapes. And you can see as we keep going, the different formulas that are up there and the different types of mathematics behind it. And you've heard of pi before.
Yeah.
You like pie? What kind of pie you like?
Like chocolate pie.
Chocolate
Or
pie. there you
pumpkin.
go. I thought you were talking about like real pie, pizza pie, right? That's what we were talking about it back east, right? Pizza pie, that's pie.
None of that Chicago
This
stuff.
is fruit pie
No,
back
no,
here,
no.
right? But here we go. So we can see a lot of the different, everybody cracking up about pie and different things right now,
I
but
think
that's
it's the
fine.
Chicago dig that people are in for. Here we
You know,
go.
the Chicago thing is not even a pie. That's
It's a
like
casserole.
a soup that they
It's
got
casserole.
right
You
there.
gotta
That's
use a fork and
that's
knife, it's not
pie.
pizza. No.
A deep dish, it's not, you can't classify that as pie. So anyway, are you familiar with, I mean, these are pretty complicated equations, right? But to be able to build something like that, that sphere can take up to winds over 100 miles an hour. And these formulas are, see, here's the one right there for it, the airflow, right? It can take a blast of up to 140 miles per hour. Hurricane strength winds, this thing's not going to be affected by it at all. And we can see a lot of different, and as you get higher into mathematics, those things will be able to be applied to things that you're working on. Have you ever given any consideration what you might want to do when you're through school?
No, not really.
Maybe you could build a big sphere over a baseball stadium, right? Who knows, right? You play some ball, be a ball player, and build a sphere over it. Anyway, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 in the afternoon. And Austin is a 7th grade student from Rosedale Middle School, digging 7th grade right now. So if you've been Rosedale 6th, 7th, and 8th grade?
No, just 7th and 8th.
Just 7th and 8th grade. So it is.
But you could go to the elementary school Independence for cross age. That's an elective they have.
Oh, okay.
Yeah.
All right. You ready to do a little math? All right. Head on over to the board with Devin. You guys are going to start with positive and negative numbers, first of all.
All right, so we've been focusing a lot in 7th grade on multiplying and dividing with, not just positive values, which we've done all the way up to this point, but also some negatives. Now, there's a structure I think that you've been able to focus on to help remember what to do when we're multiplying positive and negative numbers. So how do you remember what to do depending on the signs of numbers that you might be multiplying or dividing, whether they're positive or negative?
Like sometimes you need the bigger sign.
Well, so you mentioned bigger. Well, what do we mean by bigger?
Like which number has the greatest value?
So if we have, let's say, for example, -6 and +5, explain what you mean.
So what we do is for 6, that would be the bigger number. So
the absolute value, and I want to make sure we get our vocabulary accurate on this so that we know we're talking about the same thing. The absolute value of -6 is greater than the absolute value of -5. And so if we were to add these together, because the absolute value of -6 is greater, then we would use the sign of -6 in our solution. And then we would, I believe, subtract the difference between the two.
yeah, because
Now
they're
that's
different
if we're
signs.
adding these two values. But let's talk a little bit about multiplying, okay? So if we were multiplying those two values, -6 and +5, what do you think might happen as we multiply these?
You might get like a different answer sometimes.
Well, yeah. The answer is going to be somewhat familiar, but there's an element in place. So we have two elements we have to consider when we're multiplying, right?
Yeah.
We have the digits, we have the integers, and then we also have the sign. What do you think would happen in regards to these integers?
You could like forget them and then just do the problem like,
Okay.
without the integers.
So here's a way to talk a little bit about what happens when we multiply with positives and negatives. You're familiar with this structure, right?
Yeah.
What is this?
A chart.
So yeah, this is a coordinate grid, right? We use it for
Yeah.
plotting points and graphing. Let's try to plot this point. Would you be able to plot -6 and +5?
Yeah.
Could you put that on the coordinate grid? Go right ahead.
There. Oh, shoot.
So that would be, remember, when we start off with the x-coordinate, we go horizontally, right?
Yeah.
So -6 is going to be along the x-axis as our x-coordinate. So instead of going down for -6, where would we place the -6?
Right here.
Okay, so that would be our -6. Now, where would we throw the +5?
We would throw the 5 on this side.
Well, no, remember, this is a y-coordinate now,
Oh, yeah.
right? So we've already gone across, right? We've put our -6, we've gone 1, 2, 3, 4, 5, 6. Now, +5. On the y, are we going up or down?
Up.
Up, because we have a positive value. So we're
Yeah.
going to go 1, 2, 3, 4, 5. All right, so I'm going to go ahead and get rid of some of these marks that we made here. I want to make sure we plot this point, -6 and +5. I want you to think about a rectangle where the corners lie on the axes and the point that we just graphed, -6 and 5. What is the area of this rectangle?
11 or 30.
30. How'd you get that so quickly?
6 times 5.
6 times 5. You multiplied the absolute values of the integers there. That's really interesting. So we know that this is an area of 30, right? And we know that when we multiply with areas, the two are very closely associated, right? Now, there's something else I want you to notice. If you were to draw a line from this corner down to our origin here, this is point 0, 0, right? is the slope, or is the direction of this line going up or down?
Down.
It's going downwards, right? So from left to right, this is angling downwards. So would you say that this is sloping in a positive direction or a negative direction?
Negative.
Negative. So because this is considered in one of our differently signed quadrants here, the slope of the line connecting the point to the origin is negative, which means that when we have -6 times +5, the solution is actually -30. And that's going to be the case because anytime you have two values that have different signs, if I have, for example, let's see, +2 and -7, that's going to be a downward slope as well. So that's going to be -14. But think about how the signs would work here. If I put a point here, what do I know about the signs of both of those coordinates?
It would be up. It would be
Yeah,
positive.
they're both positive,
Yeah.
so the slope is going to be positive. What about down here? Let's say I do -3 and -2. What are the signs of these coordinates here?
Negative.
They're both negative, but because the signs are the same, the slope will be positive. And so even though both values being multiplied would be negative, this would still have a positive product. So whenever we know that the signs are different, when we multiply or divide, they're going to have a negative product or quotient if we're dividing. But if they have the same signs, then we're going to have a positive product or quotient along the way.
Nicely done, and great use of the coordinate right there to show the -6 and the 5 and how that is all related together right there. All right, well, Austin, for some great work so far today. You've got yourself a meal, courtesy of our friends at Chick-fil-A, so congratulations on that.
Oh, look at that thing.
Who
Did you
doesn't
see
love
that?
Chick-fil-A? Everybody loves that. Austin, have you
Big
ever
sandwich.
studied or worked with scientific notation yet?
No, not
All right,
yet.
well, you know what? We're going to do a little bit right now with Iman and Ansh.
Hello, my name is Imandeep Matharu,
And my name is Ansh Patel.
and today we'll be talking about scientific notation,
Scientific notation is a way to change really big numbers
or really small numbers.
so that they're easier to view and faster to write. Right now, I'm going to talk about how to change really big numbers into scientific notation. So first, let's start off with a really big number, 5,730,000,000. Now that took a long time to write, and it's kind of hard to comprehend because of the amount of zeros in it. But when we change it into scientific notation, it won't take that long to write, and it'll be really easy to comprehend. So the first thing we need to do to change it into scientific notation is we need to move the decimal to the left until there's only one non-zero number to the left of it. So let's do that right now. And now we also have to count the amount of times we move the decimal, which if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 9. And then the decimal number that we got out from this would be 5.73. Now we have all the information we need to change it into scientific notation. Scientific notation is always the product of a number and a power of 10, which would be 5.73, which will be the number we're going to be using, and then the exponent for the power of 10 would be 9. Now you're probably asking, why 10 to the power of 9? Well, as we know, if you multiply a number by 10, it moves the decimal point to the right. And since we moved it to the left 9 times on the original number, we're going to need to move it to the right 9 times so that we can make it into the original number, which is why it's 5.73 times 10 to the 9th. And that's how you change really big numbers into the scientific notation. Now, my friend over here will tell you how to change really small numbers into scientific notation.
Hello again. So, to change really small numbers into scientific notation, it's basically the same thing that my friend earlier had explained. So, let's use this number. That took a long time to write, even though it's such a small number. We must do the same thing as my friend earlier explained, and we must move the decimal until there's one non-zero digit to the left of it. So let's count. 1, 2, 3, 4, 5. Now we got the number for our scientific notation. Scientific notation should always be written in this format. The number multiplied by 10 to the power of blank, or x for this. When writing scientific notation for very small numbers, the exponent should always be negative, since you move the decimal to the right. So now that 4.6 is n, we have to find out how many times we moved this decimal. We moved it 5 times. So our correct answer should be 4.6 times 10 to the negative fifth. 10 to the negative fifth would be 1 over 100,000. And if that is multiplied with 4.6, would get you this exact same answer right here.
And that's our lesson on scientific notation.
Thank you.
Thank you.
All right, thank you to Iman and Ansh for talking a little bit of math right there and scientific notation. 636-4357 is that phone number. We have Devin in studio with us, and we have Austin, a 7th grade student from Rosedale Middle School, working on positive and negative numbers, and now you guys are going to take it a step further and get into some fractions.
All right, so we're going to talk a little bit about multiplying and taking it to another level in regards to multiplying with fractions. So I actually want to see if we can tinker with mixed numbers and multiplying. So let's come up. I'm going to actually give you the opportunity here to tell us what 2 mixed numbers you want to work with here. So let's talk about what you come up with one, I'll come up with another one. All right, so write down a mixed number on your side. So we're going with a mixed number with what's also considered an improper fraction here. So we're playing a couple of different levels here.
Oh,
I mean, we can play with that. We can stick with that. Or if you want to try something different, we've got that too. So we're going to go 6 2/3 instead of 2 6/3, which is, I think, just 4, right?
yeah.
So this is good. We have a mixed number to work with. I'm going to go ahead and I'll take it to a different phase here. Let me try 2 3/4. Now, I want to talk a little bit about some of the ways that we are usually taught on how to multiply these and a visual approach to how we can consider this. So as you're working on multiplying these, and you know what, just for fun, let's go ahead and I'm going to add a negative here. All right? You decide, do you want yours to be positive or negative? You make it negative. Okay. Now, if you're working on multiplying these two,
Same sign.
you know right off the bat, and what you said, could you repeat that a little louder?
Same sign.
So you know that both of these have the same sign. If we're multiplying these and they have the same sign, what do we know about the product?
It's going to be a negative number.
Well, actually, remember that coordinate grid. If these are coordinates, and we go back here a little bit, and we'll erase a lot of our work here. If we were to plot that point, so negative 6 2/3 would be something along here, and negative 2 3/4 down this way. In which direction? Is
Positive.
this a positive? So we know this is going to be a positive
Answer.
One quicker way to do that, so you don't have to utilize a coordinate grid every time. If you know, if you know you have these values when you're multiplying or dividing, and you know you have 2 negative values,
It equals positive.
whatever's left will be the sign of the solution. So we know it's going to be positive. Now let's talk a little bit about multiplying the absolute values here. 6 2/3 and 2 3/4. What would be your approach to multiplying these two mixed numbers?
Make them an improper fraction first.
That's really interesting. Okay, so you want to turn 6 2/3 into an improper fraction, 2 3/4 into an improper fraction. Can we both do those at the same time to
Yeah.
split the work, share it out? All right, so I'm going to talk how I'll do negative 2 3/4. I know that I can multiply 4 times 2 because I have 2 4/4. That's 8/4, and I'll add that to 3/4. So I have 11/4 over here. Now this is negative 11/4. I want to keep that in mind. Now we have 20/3 and 11/4. They're both negative. What do we do with these?
Multiply them now.
We got to multiply these, right? So these are pretty big numbers that we're going to be multiplying here. I mean, fortunately, they're somewhat friendly. When we multiply with fractions, what is the general procedure with that?
To multiply top over bottom and like that.
Yeah, you can multiply the numerators and then multiply the denominators. So which would you like to multiply first, numerators or denominators?
Denominators.
Okay, so we have 3 times 4,
12.
and we have 20 times 11. And so this takes us to the algorithm, right? And so that's another layer, that's an additional step. Can be somewhat time consuming. So we have now the unfortunate duty of having to simplify 220/12ths into a mixed number. There's got to be a better way. Let me actually go back a little bit on our journey with multiplication. If you remember when you started learning how to multiply, we used something called the area model. Are you familiar with the area model? So like if you were breaking down like 12 times 11, you would have 10 plus 2, and then 10 plus 1. We can do that with mixed numbers as well. So if we have 6 2/3, we could break that up into 6 and 2/3, because that's all a mixed number is, right?
Yeah.
Same thing over here on this side. We had 2 3/4, and now we can just simply multiply the pieces together, right? So we have all of these 4 that we're going to multiply. Which of these would you like to find the area of first?
2 and 3 and 3/4.
2/3 and 3/4. You're going to multiply those two fractions together. Where does that take us?
6/12.
6/12. Is there an easier way to write 6/12?
1/2.
1/2. Oh, that's much easier to work than 220/12ths. This is great. I love where we're going with this. All right. What else can we multiply here?
6 and 2.
6 and 2, which is?
12.
All right. What's next?
Just add the 2.
Well, we have these, but we also have these pieces we got to fill in too, right? 2 times 2/3.
4/3.
4/3. Or we could write that as 1 and 1/3, right? Now what about over here? 6 times 3/4.
18/4.
18/4. So 18/4. That's a little easier to work with, right, as far as turning that into a mixed number. What would that be?
You divide.
So yeah, we know we can get how many groups of 4 into 18?
3. Or no, 4.
There we go, 4. Now how many would be left over?
2.
2 out of 4, which we can also write as
2 and 4.
2/4, which is
1/2.
1/2. All right, now it's a matter of combining these pieces together. What's nice is that some of them go together very nicely. I have 12. Let's start off with our whole numbers first, right? I've got 12. What other whole numbers do I have here?
That's it. That's
Really?
the only- Oh, 4.
I got 4 here.
And 1.
And I got 1. Can we add these together?
Yeah.
All right, 12 plus 4
17.
plus 1 is 17. I'm going to hold on to that. Let's add our fractions together. I have 1/2, 1/2, and 1/3. Do any of those come together nicely?
1/2.
Yeah, I have 2 1/2s, which equals
1.
1 whole. So I'm going to add another 1 whole here. And what's left?
1/3.
So 1/3. I have 17 plus 1, which is
18.
And then 1/3. So, yeah, we could try to convert into improper fractions. But there's a lot of big numbers that we got to work with. It becomes algorithm-based, multiplication, division. Coming back here with this area model for those is very useful. Now remember, these were negative when we started off. And because they're both negative, will 18 and 1/3 as the product be positive or negative?
Negative.
Well, that's
Or
going to be
positive.
that's right, because they have the same sign. So, negative 6 and 2/3 times negative 2 and 3/4 is positive 18 and 1/3.
Nice job right there, guys. Well done, and nice use of the area model also to show how you can work with some easier numbers right there. All right, we also know a lot about STEM, but even STEAM. We take the A in arts and a little bit of music right now. Music. Today we've got Tanner from the Panama-Buena Vista Music Department. How are you today, Tanner?
Doing good. How are you?
I'm all right. So what schools do you work at in the Panama District?
I work at 2 different schools. I first work at Loudon Elementary teaching TK through 6 general music and choir, and I also teach at Castle Elementary doing 5th and 6th grade band and orchestra.
All right. Well, fortunate for you today, you've got a music man over there with you because Austin does a little bit of percussion. So what will you guys be doing today?
So today we're going to be going over a little bit more with fractions. So continuing the fraction learning, do any of these seem familiar to you with your percussion background?
Yeah.
Which one seems the most familiar to you?
Quarter note.
The quarter note, right? Which is this one right here, right?
Yeah.
How many beats do one of our quarter notes have?
1.
Can you write 1 on the board for me, please? Very good job. Is any other of these seem familiar to you?
Whole note.
Whole note, which is how many beats?
4.
4, right? Can you write that on the board for me, please? Very good job. Now, if this is 1 and this is 4, do you remember what this one is?
1/2. Or no.
We got the half, right? It's
Yeah.
a half note, which is how many beats? Do you remember?
1 or 2.
2, right? So we have 4, 2, 1, right? And then we're getting into some eighth notes, a little bit trickier. Each one of these eighth notes, do you remember how much each one of these eighth notes?
16.
Not a 16.
8.
But they are an eighth of a measure, but they equal up to 1/2 plus 1/2 equals how many beats?
2. Or 4.
A half plus a half?
1 whole.
1 whole, right? Which is?
1.
Can you write 1 for me, please? Very good. And then something that you will see starting next year in percussion or later on this year are 16th notes. Each one of these is, if we have 4, if this was half and a half and I have 4 parts and this all adds up to 1, what fraction do you think we have right there?
1 and 1/2.
Half, half. If I cut a half in half, what do I have?
1
1/4,
1/4. 1/4.
right? 1/4. And if I have 1/4 plus 1/4 plus 1/4 plus 1/4, I have
4.
1 whole, right?
Yeah.
So, going into music, we have in music our 4 time signature, right? Do you remember how many beats per measure we have in a 4/4 time signature?
1 beat.
We always, when we're looking at a time signature, we always look at the very top. And the very top one is going to tell us how many beats we have per measure. So if we have a 4 on top, it means we have 4 beats per measure. And this will always tell us that our quarter note is each beat of the measure, okay? Now, if each one of these is 4 beats, I'm going to take my whole note to start us with, okay? Our whole note, if I put it right here in the open, and I have a measure right here, that leads us into our next measure, right? How long is our whole note?
1 whole beat.
Our whole note is how long?
4.
4, right? So if we have 4 beats, and each measure has 4 beats, what would that equal?
1.
1, right? So if I have 4 that takes up a little, how many whole notes would I have per measure?
1.
1, right? Going into more of the deeper fraction side of music. So, and now this would cover the whole measure, right?
Yeah.
So, if I took a half note, which is how many beats?
2.
2, right? And I go ahead and I put, we're going to keep the 4 on top, okay? To signify how many beats we have per measure?
4.
4, right? So we're going to take 4, and how many beats do we have for a half note?
2.
2, right? So if I have 4 and 2, 4 divided by 2 equals how much?
2.
So if I had 2, how many half notes do you think we'll have per?
2.
2, right? Do you mind putting a half note right here?
Yeah.
So when we're doing our music and we're counting music, we will always go 1, 2, 3, 4. Can you count that for me?
1, 2, 3, 4.
Now, you're a percussionist, so you get to go clapping, keep to the beats, right?
Yeah.
Can you clap this with me?
1, 2, 3, 4.
Now, when we do our half notes, right, it's going to be 1, 2, 3, 4, because it covers the whole 2
Yeah.
beats, right? Can you clap that with me? 1, 2, ready, go.
1,
2, 3, 4. Very good job. Now, moving on. So we have our 4 beats, right? So we're going to add back our 4 right here. The very first rhythm that you popped up, and it's the one that we always learn the first, is which one?
Quarter.
Quarter note, right? And it's how many beats?
1.
So we're going to put 1, and 4 divided by 1 is just
4.
a 4, right? So can you draw 4 quarter notes right here for me? Good job. And then make sure, because the difference between the half note and the quarter note is we just have to fill in.
Fill in, yeah.
Fill it in. So can you fill them in real quick? Very good job. Now, I brought some drums, and I like us to just drum that 4-beat pattern. You ready?
Yeah.
1, 2, ready, go. 1, 2, 3, 4. One more time, just to have fun with the drum. 1, 2, ready, go. Doing a good job with that steady beat. So we're gonna put this down for right now. So we agree that, because 4 divided by 1 equals 4 quarter notes, right? So getting into the fun, deeper fraction side of it. We said these are 1/2, right?
Yeah.
So if I have, how many eighth notes would I have to get to 1 beat?
4.
Eighth notes?
Oh, 1.
So we have half and half. Each one of these adds up to, each one of these looks like this. We have an eighth note and another eighth note. And combines, they look like this. Getting into some further rhythm. And each one of these is a
Half.
half, right? So each one of these is comprised of how many eighth notes?
2.
2, right? So to get to a quarter note, which is 1 beat, right? How many eighth notes would I need to have?
2.
2, right? So if I have 4 quarter note, 4 beats, 4, and we have how many?
2.
2. 4 times 2 is?
8.
So we have 8 eighth notes, right? So each one of these would be added, so I'd have 8 eighth notes across the board. And when we're counting this, instead of doing our 1, 2, 3, and 4, we now add 1 and 2 and 3 and 4 and. That way we can give respect to the eighth note. Can you count that for me?
1, 2, 3, 4.
And now adding the 1 and, adding the ands with it as well.
1 and 2 and 3 and 4 and.
Very good job. Now, can you clap it with me? Sounds like 1 and 2 and 3.
and 4.
Again, 1, 2, ready, go. Now with the drums, just for some good fun. 1, 2, ready, go. Very good job. Now, if these are called eighth notes and we have 8 of them, and our 16th note, how many 16th notes do you think we have in our measure?
2. Or 1.
1. So if we have, if each eighth note is a half, right, and 2 halves make a whole, right, makes 1, how many quarters do I need to make a dollar?
4.
4, right? And how many quarter notes, how many dollars would I have to make the full measure?
4.
4, right? So 4 times 4 is
4 times 4 is 16.
16, right? So how many would I have for the 4/4 measure?
16.
16. So do you see how when we have, going back to pi, when we have a nice little pi, if this would be our whole note, it would cover the whole pi, right?
Yeah.
So let's just say this is our full 4 beats, right? If I cut that pi in half, I have how many?
1/2.
I have half and half, right?
Yeah.
Which is then our half notes. So because it's half of the pi. Now, if I cut that in half, what do you think rhythm would that be?
Quarter.
Quarter note. Cutting it again in half would be our
Eighth.
eighth notes. And then one more time would be
16 notes.
16th notes, right?
Yeah.
So we get 16 pieces of the pie so we can share with everybody here. So what I'm going to do, So we said, how many 16th notes add up to a full?
1.
How many?
4.
4, right?
Yeah.
So a 16th note looks like this again. And each one of these is 1, 4, 1, 4, 1, 4, 1, 4. Do you think I can combine these?
Yeah.
So let's combine it real quick. So if I combine 1/4 and 1/4 equals
2 A's. Or 1. Or 2 fours.
2 fourths, which is our
1/2.
1/2. So what rhythm do you think I can put here in replacement of the two 16th notes?
1/2.
1/2, which is our 8th note, right?
Yeah.
So then we get, in general music, we get it called as a T ticka. Further with fractions. Very good job. That's all.
There you go. Nice job, Tanner. Some great use of fractions right there and learning a little bit more about notes. Every time you guys come in, I get more and more educated with the music that you guys do. So thank you very much for coming in this afternoon and helping us out with a little bit of music and math.
Thank you.
64357 is that phone number, and always some new and exciting things going on at NASA. An asteroid sample, and this guy's been in space for a rather long time. Let's check it out.
Our first asteroid sample return mission is back on Earth, a record ride in space for a NASA astronaut, and our Artemis II mission is making pre-launch progress. A few of the stories to tell you about this week at NASA. On September 24th, the OSIRIS-REx sample return capsule with samples of rock and dust from asteroid Bennu made its historic return to Earth, marking the end of our first asteroid sample return mission.
And touchdown of the OSIRIS-REx sample return capsule.
The next day, the sample return capsule was flown to our Johnson Space Center in Houston, where the sample material inside it will be cared for, stored, and shared with scientists around the world. The week saw another historic return from space, this one on September 27th by NASA astronaut Frank Rubio. After spending a U.S. record-setting 371 days in space, Rubio landed safely in Kazakhstan along with 2 crewmates.
Rubio's record ride comes to an end.
Rubio's extended mission provides researchers the opportunity to observe the effects of long-duration spaceflight on humans. Teams at our Michoud assembly facility in New Orleans have structurally joined all 4 RS-25 engines onto the core stage of our Artemis II moon rocket. Meanwhile, the Artemis II astronauts recently completed the first in a series of integrated ground system tests at our Kennedy Space Center. The Artemis II flight test around the moon and back is the agency's first crewed mission under Artemis. On October 14th, an annular solar eclipse will cross the U.S. from Oregon to Texas. An annular eclipse is also known as a ring of fire eclipse because the moon doesn't entirely block out the sun, but instead leaves a bright ring of sun. Learn more about eclipses at solarsystem.nasa.gov/eclipses. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Always fun stuff going on at NASA, and we'll learn about it every single week with you. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Austin is a 7th grader from Rosedale Middle School. Working a lot today with fractions, so what do you say we keep it rolling? All right, back over to the board. You and Devin, let's take a look at this.
So during the break, I put together a few sets of multiplication and division problems. We're going to reveal these pairs one at a time. And all I want you to do is tell me what you know and what you understand about each of these sets, okay? So let's start off with our first set here. Tell me what you know about both of these.
Well, one's a division, one's a multiplication problem.
Okay, that's a great start. We have division, we have multiplication. What else can we say about these?
They both have a common number in them.
What would that common number be?
9 and 3.
So, okay, so you notice that a 3 is present in both and a 9 is present in both.
Yeah.
All right, tell me a little bit more about what you noticed, or what you can tell me.
That's pretty much it.
Okay, well, could we start working out the values of each of these expressions.
Yeah.
Okay, so what can you tell me about either of these? Which one would you like to evaluate first?
This one.
All right, well, yeah, because it's right there, right? Tell me a little bit about 9 divided by 3.
9 divided by 3 is 3.
All right, go ahead and mark that down just so we don't forget, right? Now let's move over here. 9 times 1/3. How could we work this out?
You can make the 9 into an improper fraction by putting a 1
Okay,
underneath
and if
it.
we do that, then what are we able to do?
We're able to multiply now.
All right, let's do that.
9.
Yeah, that palm gets you every time. So let's go ahead. 9 divided, so 9/3, which is what?
3.
3. So now, isn't that interesting that both of these expressions that seem to have the same starting value, opposite operations, and then if you really consider 1/3, what do you notice about the relationship between 3 and 1/3? Maybe if I re-represent 3 as such.
They're one's an improper fraction, one's a regular fraction.
I would also add that if you were to reverse
It would be
the
1/3.
numerator and the denominator, you would get the other, right?
Yeah.
So that's a term in math called the
Reciprocal.
reciprocal. There you go. You know reciprocal. You live that reciprocal life.
just did
All right.
this today, actually.
Oh, just today? How relevant. Well, let's continue with that conversation. And I challenge you to utilize the academic vocabulary of this, all right? So let's try this again. All right, I'm going to reveal another set. Tell me what we can do with these.
Same thing, you could change this to 1,
Okay?
and then you could just divide these like
So I would argue then that knowing what you know about the relationship between dividing a value and multiplying by its reciprocal, what can you tell me about the value of both of these expressions? Even before we evaluate this.
like the same numbers.
It's
just
going to be
over.
4, right? And we know that because we recognize the relationship. Dividing by a value is the same as multiplying by its reciprocal.
Yeah.
I like to express that more than I like saying keep, change, flip, because those words get real easy to switch around.
Yeah.
And when we only think about it in that phrase, if that's all we know, it can throw us off. So I like to speak to the relationship more clearly with the vocabulary. Dividing by a value has the same effect as multiplying by its reciprocal. So with that in mind, tell me what I can put in this blank to have the same outcome as this expression.
1.
So I would put 1 here. Well, let's test that out, right? Because as we've discussed, we want to make sure, because what do we want this to equal? Do we know how to evaluate this expression?
You make this a 1 again underneath it.
Now, this is going to be very interesting, okay? Because there's the mindset. So tell me what you do once you divide. So you have 2 over 1, 2 whole divided by 1/2.
Yeah.
Okay, tell me how you would evaluate that.
Well, like I was saying with the keep, change, flip, we would change this one to multiplication.
Okay,
as
so
sign.
you don't
And then you would
necessar-
flip the 2 and 1.
So, what would fill into this blank to replace 1/2 here? What would the reciprocal of 1/2
2.
be? 2. So, we didn't really necessarily have to flip anything. We just used the reciprocal as its multiplier. Now, there's a way to illustrate what this looks like. If we have a bar diagram of 2 whole, and we want to divide it into pieces of 1/2, how many pieces of 1/2 do we have?
4.
So there's a lot of different ways where we can start to look at how to divide with fractions and multiply, but this is key. Knowing that relationship between multiplying and dividing and how reciprocals are involved.
There you go. Nice work. And it's funny that Devin said how appropriate, because you guys were just talking about reciprocals today and the inverse operations and things like that. And that is exactly what you were doing today. And I think it's great that you're able to see things worked out a little differently than what you may be doing in the classroom all the time, which is the whole point of math, being able to do a problem several different ways. So hopefully you're seeing that a little bit today and going, yeah, you know what, that's pretty cool the way we just did that. So Did you know that there is a math week coming up?
What do you mean, Mike? Every week is math week.
That's math
Right?
week. Well, math day, math year, everything.
Math life.
But here's Kern Math
Hashtag.
Week. We're going to talk about this a little bit right now. So this is coming up October 23rd through the 27th, a full week of family time with stories, games, and math activities for families with students in kindergarten through 8th grade. And this is our friends. They've been in last year, I know that. And Mind Research is where you can go and check out a little bit more about that. You've got the codes on there. You can always check it out. So that is coming up October 23rd through the 27th. We'll have some people coming into the studio to talk a little bit more about Kern Math Week. And it's always fun and exciting. A lot of games that they bring in, and we'll get more of that as it gets even closer. We'll be back with more right after this.
Have you ever visited California's redwood forests? Explored the vast desert? Felt the power of the Pacific Ocean? These adventures and more can be yours to discover with the free California State Park Adventure Pass. Available to 4th graders and their families, this pass provides free access to select parks throughout California, waiving the day use and entry fees for a full year. With a variety of benefits including access to museums, historic sites, and natural parks, adventure awaits you. Visit our website at parks.ca.gov/adventurepass to get your free pass and learn more about this program. Let your adventures begin at California State Parks. Hi, I'm Lydia here at Cuyamaca Rancho State Park, home of some of the highest peaks and most incredible views in all of San Diego. We are so happy to be one of the many California state parks participating in the California Adventure Pass program. This pass is available for California 4th graders and their families, waiving day use entry fees, giving families the opportunity to visit the great outdoors, historic sites, and unique museums for free for a year. Our park is over 100 miles of trails for hikers, bikers, and equestrians, as well as a reconstructed Native Californian village site here at the Visitor Center. Once you're here, you may want to explore the Stonewall Peak hike. This 4-mile round-trip hike leads you to breathtaking views of the mountains here in Cuyamaca Rancho State Park. Visit our website at parks.ca.gov/adventurepass to get your pass and learn more about this program. Let your adventure begin at Cuyamaca Rancho State Park.
We love California State Parks!
The California State Parks, we are fortunate enough to find out about the Adventure Pass, where all 4th grade students can go to any of the state parks throughout California. There were 19 of them, I think, that they were talking about, and all kids have that opportunity. You want to take a break for a minute? Yeah, well, stay right here. Stay with me. We're going to go to the phones right now. He's ready to do some work. But Emily, how are you this afternoon?
Good.
And you're a 4th grade student, correct?
Yeah.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Right now, I'm working on last night. Christopher collected 5 times as many shells as Mohammed. Together, they collected 42 shells. How many shells did Mohammed collect?
All right. Well, you and Devin are going to have about 3.5 minutes to work on this.
Great. So thanks for that, Emily. Now, let's start off with the information that we have. We know that Chris and Mohammed together collected 42 shells. Now, what I'm going to do is I'm actually going to use letters to represent each of our friends here, okay? So I'm going to use C for Chris, and I'm going to use M for Mohammed, and I know that together they equaled 42. Now, I don't know how many shells Chris collected yet. I don't know how many shells Mohammed collected, but I do know that Chris collected 5 times as many as Mohammed. So that means that whatever Mohammed collected, I need to multiply that by 5 to get to 42. I'm sorry, to get to whatever Chris's total was. Now, this actually makes it a little bit easier because I know that whatever those two values are, one is going to be a multiple of 5 of the other. So what I can do is, I can work through those multipliers and then add them together to see if they equal 42. So you might set up a table for this. If I have one column for Chris, I know that I'm going to multiply Mohammed's by 5 to get to Chris. And then when I add them together, I want to see if they equal 42. So this is one of those math problems where you can try some different things out, and if it doesn't work, try something else until you get to a solution. So maybe we start off with, maybe Mohammed collects 1. That would mean that Chris collects 5. And if we add them together, that's 6. That's too low. And that's so low, I might even skip a couple to see if I can go a little bit bigger. So maybe I'll try something like 5. Because I know that if Mohammed collects 5 shells, then Chris would collect 25 shells. And if I add those together, that gets us to 30. Now, is it 42 yet? Not quite, but I'm a little bit closer. So let's try a little bit more at a time. Let's go up to 6 for Mohammed. If Mohammed has collected 6 shells, that means Chris has collected 5 times that, or 30. Together, it's 36. So it's not quite there, but I'm closer to 42 than I have been yet. And if I go one step further, I feel like I'm going to get right there. So let's try it. Mohammed collects 7 shells. That means that if I multiply that by 5, Chris has collected 35 shells. If I add 7 and 35 together, that brings us to 42. So, based on the original information, we were asked how many shells did Mohammed collect. That's what the question is asking us to identify. And based on this information, we know that Chris collected 35, but the key here is that Mohammed collected 7 shells.
So Emily, hopefully that helps you out. Does that help you out, Emily?
Yeah.
All right, great. Thank you for that phone call. And for your phone call this afternoon, you've got yourself a pass to COM. So congratulations on that. Hopefully you and some of your family has an opportunity to go out to COM and enjoy the atmosphere out there. Who knows, might be getting ready for holiday lights out there pretty soon also. Did you like all that fraction work that you were doing today?
Yeah.
I think it was pretty cool that you're a percussionist and you had somebody coming in today and they were talking about percussion, and that's kind of what you guys were doing and stuff like that. All sorts of math with music. And how long have you been doing percussion?
Just for this year so far.
Just for this year? Good, so it's something pretty new for you.
Yeah.
And you liking it so far?
Yeah, and I was in band last year too.
Good. Well, you know what else is going to be new for you this year? You're going to be an ambassador for Do the Math. All right? This is your uniform. So why don't you hold that up, and we'll put that at camera 3 right there. And that is your new uniform. So here's what I want you to do. You are simply going to tell people about Do the Math. Can you do that?
Yeah.
And here's what I want you to do. When you go to Cooperstown again, because you're playing ball, I'm sure you're going to go again at some point in your life.
Yeah.
You wear your Do the Math shirt, tell people in New York about Do the Math. Sound good? Did you learn a little bit today?
Yeah.
Did you have fun today?
Yeah.
That's the most important thing right there. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.